Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the energy stored in a charge capacitor, and we will learn the energy stored formula can be written in a number of ways also, and when to use which formula. Okay students, so let's start the video. So the topic is energy stored in charge capacitor. So see, as we know very well, capacitor is a device which is used to store water, electric charge or potential energy, that we know very well. Now see, students, here see, let's see be the capacitance of a capacitor, we know very well. Okay, so students, after that let's see what is given. On being connected to a battery, it charges from Q equal to 0 to Q equal to capital Q. Because what will happen, the moment capacitor is connected to battery, instantly it will not charge depending upon the value of the time constant. That means tau equal to RC. Maybe it may charge slowly or it may charge fast depending upon the time constant. Okay, so see here after that, see, if Q is the charge on the capacitor at any instant, then it is given by here. Okay, so whatever is written here, that we have to understand from the very basic point of view. So students, in this situation, to understand this, we have to draw here. Let's take this capacitor is there and this is connected to the battery. Which terminal? This terminal is there. This is point A and this is point B. Okay, so you know very well, in the initial situation, charge on the capacitor will be how much? The charge on the capacitor will be Q equal to 0. Okay, and after that, if we talk about here, the moment we will connect it to the battery, what will happen in this situation? The potential across the capacitor, means potential difference across the capacitor, will be how much here? 0. Initial situation. Okay, this is which situation? Again I am writing here, initial situation. Okay, initial situation. Okay, after that what will happen, that this capacitor will slowly charge. Okay, so now what I will do here, I will make here one more situation. This is called a intermediate situation. Which situation? Intermediate situation. And let's take in this situation, the charge on the capacitor is how much? Q. Okay, and at that instant the potential across the capacitor, how much here? V dash. Okay, this V dash we are using for the potential across the capacitor at any instant, na? V dash. So at t equal to 0, what is there? 0 potential. After some time, how much? V dash. Okay, now students, after that what will happen, that here, this is the which situation? This is the which situation? Intermediate situation. Okay, whenever we have to analyze this kind of situation, like any physical quantities keep on changing, na, we need the three situations: initial, intermediate and the final situation. After that what will happen, that here, let's take here again let's take this capacitor is there, na? Point A, point B. In this situation, what is there? When the capacitor is completely charged, let's take that time, how much charge is there? Capital Q charge is there. Okay, and at that instant what will happen? Across the capacitor, how much potential will come? Whatever is the battery potential, and let's take a battery potential is V. Okay, and the capacitance of the capacitor, how much? Anyhow, C. Okay, and this is which situation, students? This is called the final situation. Which situation? Final situation. Okay, so initially what is there? Initial situation. So initially what is there? The charge on the capacitor is 0 and the potential difference across the capacitor, how much? 0. And after that what is there? In an intermediate situation, that means after some time what will happen? Let's take charge on the capacitor is Q and the potential, how much is there? V dash. And finally, in final situation, what will happen? When the capacitor is completely charged in steady state, that time how much charge is there on the capacitor? Capital Q, and the potential, how much? V dash equal to V. And I think so you know the basics very well. Here on this plate charge 0, this plate also charge 0. Here if charge plus Q, this side charge minus Q. If here charge plus Q, this side charge minus Q. Now I hope so this basics you know very well. Okay, so students, what will happen, that here, to calculate the energy across the capacitor, as I have told you, how many situations we have to use? We have to use the three situations: initial, intermediate and final situation. Now what we will do? We will make the formula by using the intermediate situation. After making the formula, we have to put the lower limit and upper limit. For that, we will use a initial situation and final situation respectively. Okay students, so as I have told you very well, see, if Q is charged on the capacitor at any instant, then it is given by At any instant means which situation? At any instant means students intermediate situation. Okay, so you know very well Q equal to CV. Okay, so see here, charge how much? Q, capacitance C, and potential how much? V dash. That means it is given by C. It is given by Q equal to CV dash, and I have made it a equation 1. Okay, in the intermediate situation. Now students, you have to know one graph also. See, sometimes it will be useful. See here. Let's take this is the charge that is keep on varying across the capacitor, and this is the potential also. So what will happen that students, the moment the capacitor will be connected to battery, the charge will be 0 and potential will be 0. We are considering initial charge on the capacitor how much? 0. Okay, so what will happen that when the potential will increase, the charge on the capacitor will also keep on increase. Okay, like this is the situation. And when the potential is V, you can see V potential, charge how much? Capital Q. Okay, so you can see very well here, students, what is happening. The potential and the charge on the capacitor is a keep on changing. That we can see by the QV graph also, QV dash graph. Okay, Q is the instantaneous charge, V that is the instantaneous potential that we are keep on changing. Okay, great. Okay, so now students, let's go to the next one. See, let the battery supply a small amount of charge dq to the capacitor at constant potential V dash. Actually, what is happening? The charge storing on the capacitor is keep on changing. Okay, so what will happen that here in the intermediate situation, we will consider that. What will consider? We will consider that this potential V dash is constant for the very small time being, and that time the battery is supplying how much charge? That time the battery is supplying how much charge? dq charge here. Na? As I have told you, we have to make the formula from the intermediate situation. Okay, great. So after that, what is there? See, then the corresponding small amount of energy du stored in the capacitor is given by. Okay, so students, this energy du is given by how much charge we have given? dq, and how much potential? V dash is there. Okay, now after that, see, dq, and what is the value of the V dash from equation 1? As I have made you, Q equal to CV dash. So V dash how much here, students? Q by C. How much? Q by C. So here I will write here Q by C. Where? From equation 1. Okay, very easy, is it? Now students, let's see. Now the formula is ready. Our formula is ready by using the which situation? Intermediate situation. Okay, now see, hence total energy U stored in the capacitor is given by. Okay, so as what is happening, charge is keep on changing, potential is keep on changing, and we need the total energy. That means what we have to do? We have to do the integration. Okay, so what it will become here? See, U equal to integration of a du. Okay, so now what will happen that students here? See, du value how much here? See, dq into Q by C. Okay, and now after that, what we can write here? See, this U equal to what is the thing is constant? Capacitance is constant because it depends upon shape, size, medium, and all that. So 1 by C will come outside, and what it will come here? It will come here Q into dq. Okay, now dq is there. So after that, you can see very well we have to put the limits. Now, so from the initial situation, we can come to know initial charge on the capacitor how much is 0, and final charge on the capacitor how much? Q. Okay, that means from where to where we have to integrate? We have to integrate from Q equal to 0 to capital Q. Okay, so students, after that, what we can write here? See, U equal to 1 by C, and integration of Q dq, it will be given here Q square by 2 by using the formula. Which formula is there? This formula I think so you know very well. X to the power n dx is equal to x to the power n plus 1 by n plus 1. Okay, this formula we have used here. So what is coming here? Q square by 2. Limits where to where? 0 to capital Q. Then what we can write here? 1 by 2c. Put the limits please. First upper limit Q square, this is the upper limit, minus 0 square. Okay, so students, here you can see very well. Then the energy stored in the capacitor. Then the energy stored in the capacitor is given by what? It is given by U equal to Q square by 2c. Now this is the energy stored in a capacitor formula. Final energy stored. Okay. After that, students, next one. This expression we can write in a number of forms also. We know very well what we know as Q equal to CV. Is it? So if I put the value of Q equal to CV, then this energy also we can write here, put Q equal to CV. So it will become here half CV square. Okay, this is the another way to write the energy. After the students, next one, if I talk about here the third one, you know very well. As now we are going to write, you can see very well, I can write here as V equal to Q by C. Okay, V equal to Q by C. So students, what will happen that here in this situation, if I write here C, U equal to, if I write here C, half Q into Q by C. Now, from here I am writing here, is it? And what is Q by C? V. Okay, so hence students, what we can write here, U equal to half QV. What is this? U equal to half QV. This is also energy stored in a capacitor. That means we can write in a number of forms. Okay, and students, if I go to the little bit backward, here I have taught you the graph here. Okay, Q versus potential graph is a V dash. So if you will see this area, what is this area? Triangle is there, and what is the area of the triangle? Half base into height. So students, here what will happen that here this area will come what here? Half Q into V. Now you have understood very well. Students, you can see very well this energy half QV is also given by water. This is also given by area under QV curve. Area under how much here? QV curve or QV dash also. Okay, great. Next students, let's see here. Now we have seen the energy. Now we are going to see the energy density between the plates. Okay, so students, you can see very well what is the energy density. Very easy, very important term also. So see, energy stored per unit volume of space in a capacitor is called energy density small u. What is this? Energy stored per unit volume of space. It is given by small u. So what we can write here, students, see in a language form also, if I write here, very easy. Energy density is equal to energy by volume. Now because number of places it will be used. That's why we have written like this. Now students, if I write here in a denotation form, so small u equal to capital U by volume. Okay, so for that students, we have to draw here the capacitor. Let's take here the capacitor is there. This is the one plate of the capacitor. Okay, and students, here this is the another plate of the capacitor. Now one plate will have how much charge? One plate will have plus Q charge, and there will have minus Q charge, and this plate will be connected to the ground. That and all we have learned. Now students, remember that here this area of the plate, how much here? This area of the plate is A, and the separation between the plates, how much here? Is small d. Okay, so students, here what will happen that here, if we will identify this volume, so can you tell me very well what is the volume? Volume will be this A into D, area of cross section into this distance d. So I hope so you have understood very well. If I have to write here this energy, U equal to, what can I write here? Half CV square, and here volume. Okay, don't mix match here. Again I'm writing a volume, and this volume, how much here? This volume is AD. Okay, now let's see here. Now we are going to simplify this. U equal to C half. Okay, capacitance formula. Capacitance is given by epsilon naught A by D. Okay, and students, V means what? Potential. Let's take here potential V, and here how much here? 0 volts. So potential difference is V. Okay, potential difference is V. So students, you know very well here, see, as whenever we have to write the electric field between the plates is always given by V by D. Now this electric field due to both the charges, a resultant electric field E, and this is also given by sigma by epsilon naught. But we are going to use this, as you know, E equal to V by D. So what is V? V is given by ED square, and down what is there? Down AD is there. So students, when you will simplify this, area of cross section will cancel, D and all will cancel. Okay, so in a very easy, when you will simplify this small e will come 1 by 2 epsilon naught E square. What is this? This is the energy density between the plates of the capacitor. Kindly see it very well how we have calculated this energy density between the plates of a capacitor. Okay, so students, you have seen all these formulas. Now after learning these many formulas and all, you may think that when to use which formula. Is it because so many formulas? So see, energy is stored in a capacitor formula. So see here, first one students, I have taught you U equal to Q square by 2C. Okay, I will suggest you one thing, because question to question changes, but when the capacitors are connected in series, that time what happens that here Q used to be constant. So when the capacitor is connected in series, their charge will be constant. So there you can use this formula, and according to this what will be there? this U will be inversely proportional to C. Now, when the capacitor is connected in what? When the capacitor is connected in series and all. That time what will be constant? Charge will be constant. That time you can use this formula. Okay. Next one, students, see second one. You know one more formula. U equal to half CV square. Okay. This is also one formula is there. This formula we have to use when the capacitors are connected in parallel. How they are connected? They are connected in parallel. That time what will be there? This potential will be constant. Potential difference will be constant. Okay. So when the potential difference will be constant, that time what will be there? U will be directly proportional to C. Okay. So first formula for the series connection, second formula for the parallel connection. Most of the time this formula will be used. Okay. Third one students, see. You know very well, one more formula we have done, half QV. This formula will be rarely used because you know very well when the capacitor is charging, charge also keep on changing, voltage also keep on changing. So this formula very rarely will be used. Okay, but sometimes maybe they may give the graph, which graph? QV graph, and they will ask this. Now area under QV curve that we have seen before also. Okay, and after that students, one more formula will be there. See first one. See, as I have taught you, small u equal to capital U by volume. Correct? Capital U by volume. So from here, students, what we can write? Capital U equal to small u into volume. Is it? What is small u? Energy density. Okay. So students, sometimes from here also they used to ask, what is energy density? We can tell very well, half epsilon naught E square and the volume. How much? AD. So sometimes they may ask in this form also. So students, how many forms are there? You can see very well. We have the first form Q square by 2C for series connection, half CV square parallel connection, half QV also sometimes for the area, and sometimes they may ask in this form also. Okay students, I hope so you have understood this energy concept very well. Keep studying, keep growing.